gonna be about the chemical reactions. Now let's start with why do chemicals react. Let's start with the idea of a chemical reaction. Reactions occur when two or more molecules interact, and the molecules change. Bonds between atoms are broken and created to form new molecules. Now let's go to the types of chemical reactions. Chemical reactions are divided into four types. Reactions according to the state of the reaction, reactions depending on the direction of the reaction, the reactions according to the speed or rate of the reaction, and finally, reactions according to the starting or heat absorption. Let's start with the reactions according to the state of the reaction, which is divided into two types: homogeneous reactions and heterogeneous reactions. Let's start with the homogeneous reactions. They are reactions that take place, and all of its components are in one phase, as in gas reactions and liquid reactions, that occur in the presence of a solvent for all the reactions. For example, the reaction of nitrogen gas with the hydrogen gas to form the ammonia gas, as in this equation, or the reaction of ethyl acetate with water to form acetic acid and ethyl alcohol, as in the following equation. Heterogeneous reactions. They are reactions that take place and all of its components are present in two phases, in another word, two states or more, and in this case, the reaction happens on the separating surface between the phases. For example, when we react the carbon atom with an oxygen molecule, we're gonna get one carbon dioxide molecule. Or when we react the hydrogen chloride with the manganese, we're gonna get manganese chloride and hydrogen gas. Now let's go to the reactions depending on direction of reaction, and it's divided into two types: irreversible reactions and reversible reactions. The irreversible reactions, which are the reactions that go in one direction only, which means that the arrow in the chemical equation is directed into one direction only, from the reactants to the resultants. And this means that when this reaction happens, the reactants are converted into two materials, aka the resultants. But these new materials cannot react back into the reactants, aka the reaction cannot be reversed. For example, when we react one carbon atom with one oxygen molecule, we're gonna get one carbon dioxide molecule. But this carbon dioxide molecule cannot react back into the carbon atom and the oxygen molecule. The reversible reactions. In these reactions, the arrow in the chemical equation identificating that the reaction can be reversed, and the resultant can return back into the reactants. For example, when we react the hydrogen gas with the beryllium gas, we're going to get two hydrogen beryllium. But this hydrogen beryllium can react back into the hydrogen and the beryllium. Same thing with the hydrogen and the iodine. When they react, we're gonna get two hydrogen iodide. But this hydrogen iodide can react back into the hydrogen and the iodide. Now let's go to the third type of chemical reactions. Reactions according to the speed or rate of the reaction, and is divided into three types: very quick reactions, moderately slow reactions, and the very slow reactions. The, the very quick reactions. This type of reaction is the ion interaction, aka ion reaction that occur in nature, and it occurs in moments. Some types of them are tie interactions, aka strong acid and strong base, in aqueous media, and they end in 10 powered by -7 seconds. For example, when we react the NaCl with the AgNO3, we're gonna get an AgCl as a participant and the NaNO3. Some gaseous reactions where the speed of the reaction increases rapidly, as is the dissociation of the nitrogen oxide compound. The following react as in the following equation, N2O4 is going to give us 2NO2. The rate of these reactions cannot be calculated under normal conditions, but there is a special voluntary technique for calculating the rate of these reactions. Moderating slow reactions. Most of the speeds of these chemical reactions can be understood. That means they can be measured in the laboratory, and from these types are organic and inorganic. For example, the dissociation of the hydrogen iodide to give hydrogen and iodine at a temperature of 450 Celsius, as in the following equation. 2Hi gives us 450 at a temperature of 450 Celsius and gives us H2 and I2. The very slow reactions. Many reactions, where they occur, they cannot be perceived or felt under room temperature, and they can be thermodynamic with Gibbs. For example, gasoline, natural gas, and coal. They are all materials that are not burned by room temperature except by sulfur or flame, so that if we mix gasoline and air in a motor cylinder and then it's thrown away over a flame, we notice that when it burns there is a crackle. Now let's go to the fourth type of the chemical reactions, reactions according to the starting or heat absorption, and is divided into two types, exothermic reactions and endothermic reactions. And as you can see in this comparison, the exothermic reactions are defined as a reaction that releases energy to the surroundings, causing the reaction mixture and its surroundings to become hotter. For example, burning, combustion, neutralization, and displacement. The endothermic reactions are defined as a reaction in which energy is absorbed from the surroundings, causing the reaction mixture and its surroundings to become cooler, for example, evaporation or melting. And as you can see in this diagram, endothermic reactions in the endothermic reactions, they react when the reactants react and transform into the products, they absorb the energy. But in the exothermic reactions, when the reactants react and transform into the products, they release the energy. And now we have reached the end of our presentation, and thank you for watching.